Hi and welcome. This time around I have a project that I've taken directly from Tom Lipton over at Ox Tools. As a matter of fact, Tom was so generous as to make his drawings available to anyone that wanted them. And the project is for a rod bender assembly. It's a pretty neat little project. I don't bend rods all the time, but it's just a fun little project, and every once in a while I do need to make hooks, and I've just sort of done it in the vise sort of crudely, but this is kind of neat. I've seen him bend up to 3/8 inch stock in it. I don't know if it'll go more than that. He didn't seem to have a problem with a 3/8 inch stock. Instead of the pin here, that 3/8 diameter pin that the stock rotates around, he used a 3/4 pin, which is this outside diameter of the base piece. And it seemed to work okay without too much effort on his part. So that's pretty awesome. The materials are pretty easy to come by, and I'm not sure that the dimensions on any of these parts are particularly critical. A neat thing about the design is that the assembly here that does the bending is actually done by a 3/8 inch pin that sticks up there. My initial thought looking at the drawings without watching his video again was that this piece sticking out here did the bending, and I thought, gee, that may not last very long. But that piece actually mates up with the 3/4 diameter of this guy that sticks proud and makes a flush surface. It's actually a really beautiful design. So the part that does the bending is a 3/8 inch pin here, which you can easily replace, and this other pin here you can replace. There is a bronze bushing, so there'll be some cost in buying a piece of bronze there. You might be able to get away with some plastic in there, but it may not last very long with the crushing forces. Let's see what else we've got here. The drawings he gave me are complete and pretty easy to understand. Tom is obviously a master, and he follows that rule that you don't double up on information, which is a standard for drawing design, that you never double up on information on drawing. I tend not to do that because sometimes I want to see a dimension on one representation of a part, and I'd also like to see the same dimension on another representation of the part. But Tom, again, is a professional machinist, so he follows the rules of the trade. And so you can find any dimension you're looking for. You just got to find it on the drawing. It's all there. He did a very, very nice job on them. So thanks again, Tom, over at Ox Tools. And let's just get started. Let's take a look at what stock I've got to make this guy. This guy's roughly 7 inches. Well, it is 7 inches long. This piece right here and this piece right here. This will make it stick out a little bit longer. So fit in a 6-inch vise jaw, no problem. Here's the stock I found for making Tom's rod bending project. And I buy all these as offcuts at my local metal supplier. For me in Southern California, that's Industrial Metal Supply. There aren't a lot of other suppliers down here. There are a couple, but not anywhere near me. But the advantage of buying cutoff is, like this hot rolled 1.5 inch rod, this guy is about 2 feet long, and it's the same price as their pre-cut 1 foot length. So that's a great find. I always buy those when I find them, even if I don't necessarily need them, because I'll use them later. This guy has a really weird proportioned angle iron, 1/2 inch thick, which Tom spec'd. It's more than 3 in this direction, obviously a lot more than 3 inches in this direction, but I can cut it down. And the advantage was, instead of paying full price in the artist corner, it's 49 cents a pound for steel plate. So this was fairly inexpensive, and we'll just clean it up. And these are some hot rolled cutoffs. And that should be everything I need to make this project. I am going to have to dimension these. I have to spend a fair amount of time dimensioning these, so rather than make you watch all that effort, I'll probably bring you back. One thing to note, though, is that when I'm cutting this angle piece, I have a trick that I learned from someone else's video that I'm going to use. Let me show you what that is. So my first intuition was to take the angle piece, pop it up here with the long part sticking out, and that would go really great until you get to the end. Then I'd be cutting over 4 inches of material, 1/2 inch thick, which, you know, it would cut much more slowly, not just because there's so much more material, but because the tooth pressure, individual tooth pressure, would be spread out over 4 inches instead of 1/2 inch. So even the tooth pressure would go down. And if you increase the tooth pressure, you might overfill the gullets and then cause your blade to break or stick or get damaged. So one of the tricks you can use when you're cutting material like that is to flip it like this so that you have a consistent thickness all the way through. The clamping isn't quite as good, but it's still more than adequate to do the job. So that's what All right, so I figured I'd start with the base part first, the part that clamps in the vise, and I've labeled the vise on the top sides. Not that it's really essential, but just to keep me honest. And we're just going to load this guy in here. And I think, maybe so I can get my 0 and repeat it, let's clean this off. We'll just use my vise stop and come up against it. And I'll set my zeros based on that. And we'll start. First, we're going to drill and tap a couple 3/8 inch holes back here, 3/8 16, and then we've got to remove a 1.5 inch section out of the corner of this where we'll be welding the rotating post on. So that's a later part of the project, but we're going to get this part done and knocked out. I left the sides of this rough sawn because I like the look of it. So what I'm doing, which is how Tom has his drawing made, because that means the dimensions of this aren't critical width-wise, but the way he's got it drawn is everything's based off the center line. So he gives center to center distance here. It does count off this edge, which I did mill to be flat, but the sides I left off, which means they're sort of rough to calculate distance based on. So we're using the center line instead, which makes it pretty straightforward, and that's where we're at. So it's plus or minus 2.25 either side. Alrighty. So that's those two guys. Next, the design shows nipping a 1.5 inch diameter hole where the center is offset by 0.54 off the side, 0.25 up from the bottom, and that's where we're set right now. Well, I gotta tell you, this is only cold rolled or hot rolled steel, but it's cutting through it like butter, this cutter. And that's all there was to it. That was pretty trivial. So that's it for this piece. That's a really nice cut. I just got to deburr a little bit, not even much of a burr. One mistake people make with annual cutters that I've read about, at least on the internet, is people running them too fast. Got to run them slow, or you, especially the high-speed steel ones, you can burn up the edges because they are very fine, a very sharp edge on the inside with a very small amount of material, so it can heat up easily and you can damage it. Next up, we're going to make the plate that the rod lies against that supports it for bending. It gets bent around a mandrel. This is just the piece that prevents it from going this way as you're trying to bend it down here. By the way, when I divided 5.5 by 2, I came with 2.25, and I'm probably the first person on the planet to do that. Should have been 2.75. He has the slots most closer to the edge. I'm not going to worry about that. I'm just going to maintain the 2.25 so I don't have to remake the part. It really isn't a big deal. So we're just going to do that right now. And what I'm going to do is I'm going to drill a few holes. They want 1/2 inch in, and then up to 1.5 from the edge, and I'm just going to punch a bunch of holes with the drill before I go to the end mill. This is a 3/8 inch mill drill bit. And I've got the mill slowed down. This is just mild steel. And he actually has you mill the slot out to 0.41. I'm not quite sure why so wide. That's about 26 thousandths over. I'm not sure how he came to that, arrived at that value, but I'm going to follow it anyways, because I'm so careful to follow everything else. All right, so the next hole is up 1. So we're going to 1.5. I'm actually going just shy of it by 10 thousandths so I can walk up to and get a nice clean slot. That's deflecting. I'm going to do that with the end mill. I'm not happy about how much the drill bit deflects or the chuck. So we're going to come back and follow that up with an end mill. So we're just going to use a 3/8 inch end mill here and nibble at the sides of this slot. All right, so here are both slots, and you can still see a little gink on both sides where the drill bit deflected. That's kind of sad. Learned my lesson there. Don't do that again. Instead, just nibble away with the end mill. Works great. This is a 4-flute 3/8 inch end mill. Had really good luck with it. The next part is the center pin, which is sort of the mandrel which the stock is bent around. And I noticed in one of Tom Lipton's recent videos, he used a straight 3/4 inch piece of material rather than the smaller 3/8 or just slightly over 3/8. But these are replaceable pins, so I'm going to make one of each. I just got some 3/4 inch 4340 stock, and which is really strong alloy steel, and I'm going to use that. It's not hard. I think it's in a pre-hardened state. I'll take a look at the Rockwell hardness on it. It would be nice if it was in the Rockwell 20s or 30s at least, because that would make it stronger rather than completely annealed. So first I'm just going to do a 3/4 inch piece, full diameter. That's some seriously hard material. I'm going to go check it on the Rockwell. I checked this sample and it's Rockwell C about 17. Not as hard as I thought it was. This alloy steel really cuts with some difficulty. Now I'm just going to make the .380 center version. I did the full 3/4. We're going to do another 100,000th depth of cut pass. This is very hard material. This the feed rate is like only a couple thousandths of revolution, 3.5. I probably need a faster feed rate. Still getting a little bit of chatter. Great surface finish. Light passes. Light passes don't leave a very good surface finish on this material. 50,000th depth of cut leaves a mirror finish. This is a 18,000th depth of cut, and it's nowhere near as nice. And that's it. There's my mandrels, the 3 of them. .380 as Tom spec'd, a .750 like he did for his latest bending. I guess this controls the radius, and this is just a spare because I did my Rockwell hardness on that one. So I'm dimensioning some cold rolled steel, and normally I can't get any kind of surface finish on it, but the truth is I've never tried pushing it this hard before. If you take light cuts, it's terrible. So what I did was I am taking fairly heavy cuts, 100 thousandths depth of cut, and also the feed rate is up at 7 thousandths of revolution, and then you get a pretty decent surface finish out of it. Very frustrating because I've never been able to do it otherwise, but so I'm trying to take this last bite at 101 thousandths to take everything I need at one time, because otherwise I'm going to have to take light passes and then the finish will go to hell. So also my RPM, 680 RPM. If I did it slower, also I wasn't breaking chips, which is why I started speeding things up. But the surface finish is pretty fantastic. especially for cold rolled and hot rolled steel. This is cold rolled, I think. All right, so if I did this right, this will be on dimension and a really nice surface finish. And oh, look at that, 2/10 over. That's that'll work. Ooh, actually 7/10 under. That'll still work. This is the shaft that the bending arm rotates around. So we needed 1.5 inches, and it's 1.4992. So it's around 1,000th. So that should be good. So we got to bore out the inside here. By the way, here's the chips it was making. Some unbroken, some broken, but nice, beautiful blue. All right, just drilling to 3/4 inch depth. We're actually going to go just shy of that. We're going to bore the final size out. So next up, before I bore this out to final dimension, I thought what I'd do was something that Tom doesn't have on his drawing, which I don't think will hurt anything, but it'll make it easier when I flip this over to drill the holes and find the center, which is to drill a rough hole. There is always a risk when you're drilling a hole like this, though, that the drill bit will wander, but I don't think it's too precise. The holes on the other side are just for the cap, the retaining cap, and that floats on the outside of the bending arm, so I don't think that's going to be a problem. And if I take this slow, I think I should be able to get a decent hole. We'll just try it and find out. Oh, you saw that wobble? I saw that wobble. Never mind. I'm going to try a stubbier drill bit. Nope. I think what I need is a center drill, something a lot more rigid than this, and then do this guy. All right, so no wobbling there. That might give me a better chance. Guess initially we'll hunker up on this screw machine drill bit. Oh yeah, that's a lot better. Now that we got it started, go to a longer drill bit. Okay, that should work. So now we're just going to bore out the inside. Okay, so that's a dead-on fit right now. So we need to take off just like a few tenths, which means sandpaper. Okay, so a little bit of sanding. That's the kind of fit I want. Oh, that depth is perfect. Look at that. That sits perfectly flush. That's exactly what I wanted. Piston fit. So we're going to call that good. This cold rolled steel, though, or hot rolled steel, yikes. Is it a horrible finish in there? Probably because I wasn't taking big bites. Yeah, anyways. Looks like I got the drill bit length nearly perfect. This is actually 50 thousandths long, so I still need to face this guy off to final length. That was pretty high-speed parting. That was 440 RPM with this Kennametal tool. It works really well. These are quite expensive, but I think worth it. As a parting tool, it's pretty amazing. It does a much better job than the inexpensive Chinese knockoff ones, and the inserts are far superior as well. Well, today, this is my go-to calipers. I've been using these since Shars sent them to me like 3 or 4 years ago, and they're my daily calipers. And interesting, I use the thumb wheel a lot to position this, and the only thing that holds the thumb wheel on is a plastic piece that has 2 pins, 2 little plastic pins, and a it threads into one little plastic post, which broke off apparently, or came unglued. I can't really tell, but that's an unfortunate design choice on their part, my guess. I'm going to see if I can glue these back together and continue using them because I like them. But something to note, I told you I'd give you feedback as more came in, and more has just come in. So I faced off the other side, and I used a center drill to get the angle right. I have a 60-degree angle center finding thing for my just a rod that I ground to center 60 degrees, and I use it for finding centers of parts when it's not critical, and this is definitely not critical. So we're going to do that, and we're going to drill and tap the 3 holes in the bottom. This is the method I use when I'm only looking for a few thousandths accuracy on center finding, and since I put the bevel on here that matches this, which is incidentally a piece of tool steel, I drop this down and then I go back and forth and see what the distance is on either side, find its halfway point, both X and Y, lift it up, re-put it in, and do that over and over. And I find that I get within a couple thousandths. So I'm going with that method because these are just bolt holes to mount the 3/4 20 screws that will hold the plate on the bottom. And so they're going to have a lot more latitude than just 1 or 2 thousandths. This isn't super precision work. I have compared this method to the Blake style, and it compares favorably. That's how I verified that it's a couple thousandths. The next step is to drill these 1/2-inch deep holes, tap for 1/4 20. It's on a 1-inch diameter bolt circle, so I'm just going to use the bolt circle feature of my mill to do this, to make this hole, and should be just fine. And he set the depth at 1/2 inch, but you could actually go deeper and not run into this inner bore, which is interesting. I guess if you want to make it for different length thread screws, if you have very limited selection, you don't have to cut them off and clean up the ends of the screws, you could go a little bit deeper and not run into the bore on the other side, but I'm going to follow Tom's recommendations. And we're done. So tapping blind holes, power tapping blind holes is risky. I was using the DRO on my quill. I left a couple tenths extra depth so that I wouldn't bottom out. The first hole was really close to hitting it or hit it. I was better on the second ones. All right, so here's the finished part, and it's done. This hole was not spec'd by Tom at all. I put it in on my own. It just seemed like it would make it more convenient for me to line this, so I used it. And another thing to note, the next part is the plate that goes over this. The bending arm rotates around this piece, and so the plate holds it and prevents the bending arm from falling off the bottom. So that's the next piece to make. And the last part will be the bending arm bracket because it's the most complicated. Now, to get a better idea of what's going on, this part here gets welded right there on the side, on the top and on the bottom. And this will challenge my welding skills because there is a moderate amount of rotating force on this because the arm is mounted low on this. So it is going to try and put some rotating force to make this try and fall off of here. Which is going to make my weld more important. The top part needs to be flush, so I'm going to run a weld bead down the center there. Then I'm going to have to re-mill this flat over here. It should be challenging. Hopefully my welding skills are up to it. I'm not sure they are. I'm a mediocre welder at best. Tom has also started as a welder, I think, so he's more or less an expert welder. but the fit's great. Well, I made the last piece off camera, and it might have been interesting to show. I wasn't shooting it when I was doing it, but this is some hardened shaft steel, and it was interesting to work with because it was about Rockwell 25 on the outside, and the inside somewhat softer around Rockwell C 8 to 10. But it cut really nicely and left a great finish. This piece goes underneath this piece, and then the part that I still have to make slides over this. Now I cheated a little bit. This is the part I just made, which just leaves me with this piece and the bronze bushing. But rather than buy a big chunk of bronze to make this 1.5 clearance 1.75, even if you buy the hollow bronze, you'd be spending some big bucks. And at McMaster-Carr, they have these bronze bushings, the exact right size, already done for me. This one's heavy duty, and this one's regular duty, bearing sleeves. So I thought I'd give them a try and see how they work instead of making my own. Because, like I said, these were like $5 a piece, and the bearing bronze just for 6-inch section would be about $100, and that's on eBay. But the last part I have to make here is by far the most challenging part to make. And in typical Tom Lipton fashion, besides being functional, it's very nice looking. And so there's going to be a fair amount of extra effort to make it look good as well in this part design. There's a lot of steps in making this. Each individual step is simple, but if you get the order wrong, the work holding situation is going to be a real pain. So we're gonna see what we can do if we can if we're up to the task Tom set before us here. So my first step, I think, is to rough out most of this material here so that I can turn this part round on the end here. This last 1.5 inches, 3/4 inch diameter, that's going to be a bit challenging all by itself. So that's going to leave a big square chunk of material down here that I can hold on to in the lathe to turn that, which will be a pretty interrupted cut. So I want to remove most of this material first. So I've got to take a chunk out of this like here. And I've got to remove the side pieces down to here. It's also an awful lot of stick out. I might need to put a center in that as well. We're gonna wing this. I'm gonna do the best I can with it, but I might very well screw this up because this is a challenging part to make. I'm sure Tom would see this as very easy. By the way, if you were wondering, here's an example of what I was talking about earlier where Tom follows the rules of the trade, which is never duplicate measurements on a drawing. So if I was interested, his reference is this side, except this is sanded. So I wanted to start on this side, use references from this side. So if I want to know the length from here to here, which I don't know, it's as simple as subtracting 1.38 from 3, but you notice he wouldn't put it on the drawing because that's a duplication. It's unnecessary information. Now, I usually put on information drawings on the way I want to build it, and maybe he did exactly the same. So sometimes I will duplicate information. If one operation comes from one side, the other from another side, then I will put measurements both directions just to make it easier for me when I'm doing the part. But again, don't be surprised if you get a drawing from someone who knows what they're doing and they don't duplicate any distances. Like he didn't put 1.5 up here because it's down here already, and that would be duplicating information, and that's a big no-no in proper following the rule design, drawing design. Alrighty, well, enough stalling. Let's see if we can get to this part. All right, so I've done my layout lines here, and this is all material. We removed this out here as well. And it shows me roughly where that radius should be. I think a 3/8 inch end mill might be a nice looking radius for this intersection right here. So I've got to remove all this material, but actually initially I'm going to remove material right down to here and leave this square portion intact so that I can hold this in the lathe to do my offset turning for this guy, for the round portion right here, this guy right here. It's actually this piece a little bit long in this direction. My reference side is over here, as Tom used that as his reference for his drawing. And so I use the same reference point, and the fact that it's a little long doesn't matter. That just means this sticks farther up the pipe, which is not a problem. So I think I've got my marks for my 2 3/8 inch dowel pin holes. Here's the center of the circle. And I think I'm going to use an annular cutter to cut this out when I get there. The small annular cutter, well, smaller, 1.5. I have a 1.75 annular cutter, but the problem is that one doesn't, you don't remove all the material. If you look at a side profile, you see that this top part extends just 1/2 inch up here, and then the bottom part is 1 inch where the bearing gets press fit. That's a little bit tricky. I've also marked the material that gets removed out of here from the side profile here. And I'm thinking I'm just going to use a coarse end mill, a roughing end mill to remove this material. I was going to bandsaw it out, but I think I'll have better luck with this thick of material with the rough end mill. I know that bandsaws are faster typically, but I'm still a bit of a novice and I tend to not get as straight a cut as I like. So I'm going to use an end mill to do this because I've got better control that way. At least the machine has the built-in hand-eye coordination that I lack. So we're going to head over to the mill and rough out this part. So work holding is going to be a challenge no matter what, but what I think I'm going to do is I'm going to remove the 1/2 inch depth of material off of just this section right here. If you can see that, yeah, you can see that. So I'm just going to remove this part first. I'm going to flip it on its side and remove all of this material going back to here on each side. The first side will have, I'll have plenty of gripping. On the second side, this part will be protruding out, so there's going to want to be some chatter. So we'll have to play it by ear, see how that works. Maybe we will be back to the bandsaw for the second side. I'm not sure. There's the first part done. Now we got to flip it on its side and remove a bunch more material. This is probably going to get more and more problematic because as I remove more material, there'll be less support. So when I clamp the bottom, there'll be nothing clamping on this section right here, for example. So you can see one of my foops here, and it damaged a little bit of the material I care about. Actually, yeah, a fair amount, unfortunately. Hopefully it doesn't scrap the part. So what happened here was, even though I had a little bit of brake on both my X and Y axes, and I was holding on the hand wheels, the roughing end mill caught because I was trying to do a full 3/4 inch depth of cut. I wasn't doing that big a bite, but it's actually easier with a big bite than a small bite because I was skimming along the outside edge and it just caught and it yanked everything, yanked the table and pulled the cutter right into it because it turned it into a climb cut. I wasn't doing a climb cut, so I was going in and then coming back this way, which was a conventional milling. Yeah, I screwed this up. All right, so I went over the bandsaw and I removed this material here and realized I just made an order of operations mistake. So when this was all a solid material, removing this material here was a mistake. I should have removed all of this first, then taken this over to the lathe, turned this part round, and then come back and remove this because it would have given me a more stable thing to grab onto. Now I don't have that, and that was bad. Of course, this was definitely bad. Look at the chunks of metal ripped out. It just yanked the table, even though I was holding on to it with friction. It just shows you, if you're an experienced guy like Tom, you probably never would have tried it. This is the tough lessons you learn. So we're going to try and turn this in the lathe next, as long as I've got a little bit of extra supporting material here, and then I'll bandsaw this off after this part, and this part I'll bandsaw it off rather than taking the end mill. I thought that was a good idea. Live and learn. All right, so we're going to make this round first because after I remove this material here, it'll be a lot less stable. I measured and put a mark in the center. This isn't critical, it's just for where the pipe goes. Actually, none of these measurements are critical other than the center diameter, so that shouldn't be a problem. And we got in our 4-jaw chuck and it's off center. And we're just going to turn it. It's going to be an interrupted cut. And we're just going to turn this part round to 3/4. And I think we're going to try 440 RPM. Hopefully that won't be too much. Let's see how stable that is. So I don't know how hard this is for you to see, but I've scribed a line in the Dykem, and I'm just going to sand up to that line, and that will be my part. I probably can take this over to the bandsaw and cut these corners off to save myself a lot of sanding time. But other than that, I think we're going to be good. Well, let's try the first assembly. So I got this mostly round. I do not have Tom Lipton's hand with a file. There's definitely some high spots here. I need to scribe another line to get this better. I have terrible hand-eye coordination, so I was not impressed. So this guy fits here, and that's an excellent fit. I don't know if you can see that. There you go. The bronze bushing I pressed in this case just using the vise. I didn't even go to the hydraulic press because it really wasn't necessary. And this is kept in place with these 3 screws, which are just right here. I think the fit's a little close because, yeah, if I tighten this, I need to remove some material off the bottom of this, because if you tighten this all the way down, this guy won't move at all. Yeah, locks it in place completely. So I think it needs a little bit of clearance, not much. It's partially because it presses up against the weld in the top, and I got rid of almost all of it, but there's still a tiny bit left. So I took my Dakanishi die grinder and took off a little bit of material, and I think we're good now. This thing's been really handy. I bought it on eBay used, and it was supposed to be in working condition. It wasn't. It didn't work at all. So I had to send it back to the manufacturer. And I got my money back on it because it didn't work and they didn't want it back. So when I sent it to the manufacturer, it cost me almost 200 bucks to get it repaired. So I did have to invest a fair amount in it, but it did end up working. So now we're good. There's enough clearance that when this is tight, it'll still be able to turn. Probably could use a little bit of lubrication too. This is an oil light bearing, so it's pre-lubricated to some degree. Yeah, it still can rotate freely with this tightened all the way down. I think 3 screws are nice looking. Probably not necessary for this application, but I guess I'll defer to Tom again. Okay, so that's that part, and that's looking really good. I think that's enough range. I might have to in-cut a little bit here at some point if I need to rotate more than I planned. And I guess we'll start with the pin that he prescribes in his drawing. And I'll put both pins in here, although they're probably both not necessary. And when this got hot, it changed the dimensions of these holes a little bit. They were loose before, but I might have to run some sandpaper in there to get these together to go smoothly in and out. Now they used to. They were for a while. Now let's try that. This was my first fit, so I took an arbor that's split, put in my drill motor and cleaned out the hole, and took up the couple of tenths that was the problem. I also cleaned up a little bit of the weld here. There was just a tiny bit sticking up and it's causing this to stick. So we're good there. So let's put this in. Okay, we're good there. And I don't need the second pin. These are the larger diameter pins. So next up, we just pop this guy in the vise and give it a try. Whoops, forgot one difference. Got to put on my handle, our giant lever arm. Now, the problem with my bench is that where the vise stands, it's not really attached to much of anything. It's just free floating above the ground. So I'm not quite sure how well this is going to work. I'm going to need a new vise location, I think, before this is over. I thought I'd really give this a go, so we're going to start with something hard. like this. So you'd have to preset this guy here. And this is some heavy-duty aluminum welding wire. Oh, and look at that. Just like butter. Boy, that was really easy. This thing's amazing. It took a bit of force, but we got it. All right, all right. We'll try something a little more challenging. I actually don't have much in the way of round stock in stock. So also the position of this sets the minimum length you've got to have stick out for the bend. So let's see, are we in frame? Yes, we are. Okay, so how hard is this? Not hard at all. Not hard at all. That's really easy. So let's try a compound bend there. So let's try that. And how about this? So I noticed that I would love to be able to do 180, although there's probably no way to do 180. So that was trivial. That was on some 1/4-inch stock too. That really was snazzy. Once might be nice to put some marks on here so that you know where your bend's going to end up and to help you predict where it's going. But I think the bottom line is this thing's a great success in spite of my huge number of errors in this project. This was one of my worst projects. But I thank Tom Lipton for the idea. It was really cool. And I had a lot of fun making it. I learned a lot. So I think it was a huge plus. I've seen Tom do some 3/8-inch stock. I don't have any 3/8-inch stock. Let me go look. All right, well, I think this is too excessive, but let's see. No, that's a bit too much for it. I was able to bend it a little bit, but it's gonna damage it. So I think maybe 3/8 and under. Well, 1/2 inch was too much. 3/8 is, I've seen Tom do 3/8 with it, so I'm sure it can do that. You might have to switch to the larger diameter center mandrel like one of these guys. And then maybe, I don't know about this pin on this side, it is hardened. So got some nice options. By the way, this isn't limited to round stock only. You can also do flat stock. This is 1/8 inch by 1/2 inch mild steel stock. And it bends that without any issue whatsoever. Not a problem. So very cool. I want to thank Tom again for the project, and I just wanted to thank you all for watching. Hope you had a good time, and I hope you learned something from my huge multitude of mistakes I made this time around. Anyway, see you next time.